My name is Abhishek Jain and welcome back to the tutorial series on how to write a quantum program with the help of an open source Python library known as Qiskit. We have already installed a Qiskit along with setting up an IBM account for accessing an actual quantum computer lying on an IBM cloud, so we are all set to write our first quantum program. Whenever we understand or try to learn a new programming language, we always start with writing a hello world program. But today also we are going to do the same thing, but this time we are not going to see any hello world popping up on our terminal. Rather than we are going to create a very simplest program which we can call it as a hello world program for the quantum computer. So in quantum world, whenever we write any quantum program, we are actually trying to build a quantum circuit, right? So what is quantum circuit? Quantum circuit is nothing but it's just a kind of representation of qubit, and on qubit, what kind of operation we are applying through by using a different gates, basically, right? So in today's video, we are going to create a program which will represent a val state. Val state is nothing but it's just an entanglement of qubits. When I say entanglement, it means that we just wanted to establish a relationship between two qubits. We're gonna understand this with the coding. To create a val state, we have to use two logical gates. One is the Hadamard gate, and the another is the control NOT gate. So to just get the information about all the gates which we have, you can log into the quantum computer IBM website and you can come here on home. Here you can go to the create a circuit. Then here you will see that gates glossary, and here you will see all the gates which we have, right? And to just get more understanding, you can just come here and you can just create whatever kind of circuit you wanted to create. Now I'm just gonna explain how can we build this kind of circuitry through the Qiskit program, Qiskit module on Python programming language. So before actually writing a code, we have to import all the modules which we have in Qiskit. Okay. Now the next thing which we have to do is, so we are trying to build a quantum circuit which will represent a val state, right? So before that we have to create a quantum register. So what is quantum register? Quantum register is nothing but it is just a collection of qubits, right? So in classical computer also, if we say 32-bit, it means that the size of a register for the 32-bit operating system is 32-bit basically. So it's the same kind of register, but this is for the quantum register. Now again, similarly, we have to build a classical register, okay? And we are going to build a classical register of 2 bits. So why we are doing that? So that we can just measure the qubit state in the classical registers. The next thing is we have to build a quantum circuit. So to build a quantum circuit, we have this method called quantum circuit, and we have to pass a quantum register as well as the classical register. Now the another good feature which Qiskit provides is at any given point in time we can just draw our circuit, right, and we can just see what exactly happening here, right? So we have a lot of, why we have a Q30 Q3, because let me just open a new notebook. No, not I mean, you can just understand this one is the first qubit and the second qubit, and this is my first classical bit and the another classical bit, right? So we have just created a quantum circuit with having two quantum registers, two qubits quantum register, and two bits of classical register. The next thing which we wanted to do is what kind of circuit we want to build. We wanted to build a circuit which would look like who's that? Okay, I think, yeah. So we wanted to have a Hadamard gate on a first qubit. How can I do that? So doing that, what you have to do is qc dot, there is a dot h which is a method to represent a Hadamard gate, and we have to apply this on a first qubit. Okay, and then if I just draw, and there is another way of drawing our circuit. Let's first put this one, and in a similar way, what I can do is I can just represent them more attractive way by having MPL. This would give us more colorful representation of our circuit. So we have applied a Hadamard gate. The next thing which we have to apply is we have to apply a CX gate, and for CX gate what we wanted to do is we wanted to create the control qubit is going to be the first one, and second one is going to have the value depending upon the value or the state of a first qubit. So if it is going to be 0, then nothing will happen on the qubit second, but if the first qubit is having a 1, then whatever the value we have in a qubit 2, it is going to be inverse, right? And if I just draw equals to then we can see this entanglement has been done. So it means the relationship has been done. The next thing which we have to do is we have to just measure our qubit, basically the qubit state, into a classical state, right? So for that, what we can do is we can just copy this again and we can just put it here on it and see the same circuit has been built. Okay, once the circuit is done, then we can execute this circuit on our own machine, and once we are satisfied, okay, now my circuit is working fine, then we can just go to the actual quantum computer and then we can run. But in today's video we are just going to simulate on a local. In the next video we're going to run the same circuit on a quantum computer, actual quantum computer, and see how the observation is different, how the output is different, right? So for that, to just in the interest of saving a time, for simulating, for the running on the same machine, what we have to do is we have to use the air component of Qiskit, and here I'm just getting this get backend as a quantum disco simulator, which is, you know, the simulator. There are three simulators: quantum simulator, then the state vector, and the unitary. We're gonna see that in our upcoming videos, right? And the next thing is, once we have this, then we can just run this line of code where we are executing our circuit with the backend is simulator, which is quantum simulator, and we are extracting the result of it and storing in a result variable. And then what we have to do is we have to just import a one plot histogram from the visualization, which is also in a Qiskit library itself, and then we can just use this line of code to represent how our circuit is behaving. Here you can see this, our qubits, either it is having 0 0 or it is having a 1 1, right? So it means that our circuit is in a well state where it is, you know, representing, it's very ideal situation. But when you are going to run this circuit on an actual computer, you will see that 0 0 as well as 0 1 and 1 0 and 1 1. That is why, because the actual quantum computer has some error, or that error we call it as a noise, right? But here it's an ideal situation, so we are getting the 0 0 and 1 1. That's it from my side for this particular video, but in our next video we are going to understand what does it mean and how can we build a simple application to utilize this computational or this superposition and this entanglement to just achieve, you know, the faster computational based on our real-time problems, right? So as always, thanks for watching this, and stay healthy and keep learning about stuff.